Welcome to your first official assignment for trigonometry. So right now it seems like it's a lot of notes on the board, but I want you to take time to write these notes down as I explain them to you. You can pause this video and write them all down if you want, or you can just wait till I explain them all and then pause it and write it down. Now you see you got a top half of the board and the bottom half. Top half, they have the graph, which is when you see this dotted line here, the dotted line stands for the function sine x. So as you see the graph, the dotted line, which is the graph of sine x, that's what sine x looks like. So it looks like a graph that's kind of like this. And then when you see the solid line, that's the graph of cosine x. So the graph of cosine x kind of looks like a U shape almost. So sine looks like a sideways S, cosine looks like a U shape, and you can see it on the graph. And the points on the graph, as you see on the x-axis of the graph, they're in the form of 30, 60, 90, 120, 150. They go up by 30s. So if you had your calculator, make sure your calculator is in degree mode, and I want you to practice inputting these values into the sine and cosine curve. So as you look at the sine curve, which is a dotted line, look at where the first dot is. The first dot is on top of 90. So if you go to your calculator, make sure it's in degree mode, and if you input sine and then hit sine 90 and then hit enter, it should get 1. So as you see on the top of the graph, the sine curve is at 1. And so that first dot, when you put in 90 on the x-axis, if you look at the y-axis where the dot is right on side of 1. So sine of 90 should be 1. Then look at what the next dot is. The next dot is at the point 180. So if you hit sine of 180, as you see, it's right on the x-axis, so that means it should be 0. And vice versa, if you put in sine of 270, you see where that dot is, it's way on the bottom, so that's on -1. So sine of 270 should be -1. Likewise for the cosine, if you see where the first dot is, it's on the y-axis at 1, but on the x-axis is right at the point, is above the point 0. So if you plug in cosine of 0, it should be 1, because that's what the point is on the graph. So what I'm doing now is showing you how to look at the graph if you didn't have a calculator, but I just wanted you to verify with your calculator that these are the actual points. Likewise for the 90, you see with the cosine curve, which is a solid line, punch in the cosine of 90 and the dot is right on the x-axis, which means cosine of 90 is 0. And if you plug in cosine of 180, you see where that dot is all below. So cosine of 180 should be -1. So that's how you read this graph. And the solid line is the cosine once again. The dotted line is the sine. So what we're going to do in this assignment is we're going to make sound. So you know that sound is made by sound waves. So pretty much where this graph stops at 360, that's classified as one period. So if I was to go past 360, it would just redraw the curve and it'll make a long wave. So this is how sound is made. So if you have a long stretched out curve, that's either a high or low pitch, and when you have a short curve, that's either high or low, depending on what the long stretched out one is. So that takes care of the curve. And you see the next box, it's boxed around phase shift. So I'm going to show you how to find the phase shift. You have a section in the homework that explains how to do a phase shift. So a phase shift, first of all, it has to be in the form y equal a sine bx minus c. When it's in that form, then the phase shift will be the opposite of c. You see that c is negative in the formula, so the phase shift will be a positive c divided by b. b is the value that is attached to x. So that's how you do the phase shift. So looking at an example, let's say we have y is equal to 4 sine 3x plus 6. So that means for the phase shift, our c is a positive 6, so we're going to use the opposite, which is going to be -6. So our phase shift is going to be -6 over our b value. Our b value is the number attached to x, which is 3. So the phase shift is going to be -6 over 3. Or you can call it -2 if you want. So that's how you do the phase shift. That part is going to be okay for you. The part that the bulk of the assignment is graphing. We're going to graph the sine and cosine curve. So I want you to know how to graph it. So first thing you need to know is that when you graphing, it's going to be in the form, all the homework assignment problems are going to be either in the form y equal a sine bx or y equal a cosine bx, because as you see on the graph, you have both a sine and a cosine curve. So the formula applies to both of these. So no matter which one you get, you can follow these steps to get the answer. So first step is you need to find the amplitude of your curve. Amplitude is that first value, which is the a. That a can be positive or it can be negative, so therefore the amplitude is going to be the absolute value of a. And so that'll be your amplitude. That'll tell you how high the curve goes and how low the curve goes. Because if you look at the sine on the graph, it has an amplitude of 1, because you know that it goes up 1 and it goes down a -1. So its amplitude is 1. Number 2, that you need to find out what the period is. That means how long the sine and cosine curve go. Where do they stop at? The period will be 360 divided by b. The b is the number that is attached to x in your formula. So in our situation, the number between sine and cosine, you don't have one, so it's automatically a 1 there. So that means that the period is 360 divided by 1, which comes out to 360. And as you look, the graph stops at 360. So it actually stops at the point 360. So that'll be your period. Once you get your period, then what you do is on the step 3, you divide your period by 4. So if our period was 360, we would divide it by 4, and I equal it to r because it can, in every problem, it's going to be a different type of period. And so let's just call it r for this sake, for the formula. It'll make more sense when we go through an actual problem. So the period is r for right now. So that's the step 3. In step 4, you're going to have 5 x's and 5 y's. I'll explain that more when we go through an actual example. Your x1, I'm going to box it up because x1 is always going to be 0. And on step 3, I'm going to box that up because you always divide your period by 4. Always, no matter what problem you're in, you're going to always divide your period by 4 in step 3. And step 1, your x1 is always going to be 0. Now x2 is going to be whatever you got in step 3. You see that x2, we labeled it r because that's the same letter I labeled it in step 3. So step 3 should be your x2, which is r. And x3, for x3, your x3 value, you simply add r to itself, and that'll give you your x3 value. And x4 value, you add r to itself 3 times, and that'll give you the x4. And x5, you add r to itself 4 times. So that's the process of getting your 5 x's. Another thing I want to point out is that in x5, when you add r to itself 4 times, you should get the same value that you have in part 2, which is your period. So in x5, if my period is 360, when I get my x5 value, when I add my r to itself 4 times, I should get out 360. So if your x5 does not match your part 2, then that means you need to go back and check your work and make sure you're doing the right thing. That's something I just wanted to point out. Now, those are the x's. To get the y's, you have to plug in. So in order to find y1, you would have to plug x1 into the function and see what you got out. And I'll clarify this more as we do an example. Same thing for y2. You would have to plug in x2 in order to figure out y2. So to figure out y3, you would have to plug in x3, and so on and so forth. So I'll give you time to digest all of this in. Pause this video, and we'll go into an example after this.